Hey, good morning, physics students. We are going to be starting kinematics. There we are. All right, kinematics for AP Physics 1. What kinematics is the motion of objects and being able to calculate their motion. As a reminder, make sure that you turn in your exit ticket so that you receive credit for your attendance. Make sure you're doing that on Canvas. Our learning objective for today is I can calculate the displacement, the velocity, and acceleration of an object by using the correct kinematic equation. And then how can I calculate the displacement, velocity, and acceleration of an object using kinematic equations? All right, this is not just going to be memorizing equations. This is going to be, can I apply the correct equation to the correct situation? All right, so we're going to go through and define what all of these symbols are that you're going to see in your equations. Make sure that we have familiarity with them. All right, so symbols, you're going to have T, which is for time, A for acceleration, X for displacement, VO, which is going to be our initial velocity or the velocity it starts with, VF is going to be its final velocity or the velocity it finishes with, and you may see G or AG, that's the acceleration of gravity. And then here in the right-hand column, you will see the units for each one of those. Make sure when you answer a question, you provide units for it. So if it's 10 seconds, it's not just 10, it's 10 and then S. All right, 3 kinematic equations. We're going to go through these in detail, and it helps us describe motion. Our first one is calculating velocity, and that equals our initial velocity plus acceleration times time. Our second equation is displacement equals the initial displacement plus velocity times time plus 1/2 acceleration times time squared. And then our last one is velocity, and this is usually velocity final squared equals velocity initial squared plus acceleration plus 2 times acceleration, and then times the difference in displacement. So final displacement minus initial displacement. And these are all on your AP Physics 1 formula chart. And this is what they look like. It'll be in the top left-hand portion of your AP Physics 1 formula chart. So hopefully you've got that. It is also in Canvas for you. All right, we're going to just kind of work through our first couple of practice problems with kinematics. So read this, and what I want you to put down is, what do I know? What do I not know? And I did the what do I know, and then what do I want to do? This is a way to break down what you know and just kind of help organize it. So as I read through this, pause, and then just kind of look and go, okay, here's where you got initial velocity, here's where you got acceleration from, and here's where you got time from. And what do I want to do? What I want to solve for is our final velocity. So pause and just kind of read through the question, make sure you know where those numbers came from. All right, now that you've unpaused, we're going to figure out how fast it's moving at the end. So we're going to use velocity equals velocity initial plus acceleration times time, plug in our numbers, and then solve for it, and it's 13.5 meters per second. And you'll notice I have the number and the unit that goes with it. That's something you're going to want to make sure you do as well. All right, so here is the second kinematic equation, just how to practice using that. How far did that boat go during the time period in the question? So took that equation. Initial distance is almost always 0. So that's just something to kind of memorize. This is almost always 0 unless they tell you it's not. Velocity initial, 1.5 times time plus 1/2 times the acceleration times 5 squared. One of the things people tend to do is they leave off that squared. So make sure you include that when you're doing these type of problems. And then if you solve for it, you should get 37.5 meters. One of the other things too, when you do one of these problems, just stop after 1 decimal place. That'll be fine. All right, so we're going to work through and see, okay, let's see if this makes some sense. So I went ahead and did a graph of this motion for us on a velocity versus time graph. And if you remember from what we talked about previously, is the area under that graph equals our displacement. So there's 1.5 meters per second. And there's my first thing I'm going to calculate the area for, which is this nice rectangle. And the second part I'm going to calculate the area for is that red triangle. and the final velocity up there is 13.5 meters. So I'm just going to do area equals base times height, and I'm going to do the bottom one first. So I'm doing the square first. Notice the colors match. 5 times 1.5 is 7.5 meters. Doing the part in red or the triangle, that equals 30 meters. Oops. And then when you go to add those together, that gives you a total distance or total displacement of 37.5, just like what we got from using the equation. So hopefully what you're seeing is the equations and the graphs relate to each other. Okay, so just a couple little interesting notes there for you to check out. So velocity versus time, or velocity times time. And our acceleration part, you'll notice when it's constant velocity, it's going to be kind of a square or rectangle. And when it's accelerating, we're going to have that triangle. So just something to kind of notice on that graph. All right, here's our third kinematic equation. So velocity squared plus, and this is velocity final, plus initial velocity squared, 2 times acceleration times displacement final minus displacement initial. So we got this problem. So I'm just kind of reading through that. What I went through is I plugged in all of those numbers and where they came from. So pause here and just take a second and go, okay, where did those numbers come from? And then take a look at the algebra and everything that I did, plugging in the numbers and where they go. This step is really key, and this is one of the steps people tend to skip, is taking your time to write down what your variables are. It will definitely help you solve some of these equations. So now that you've unpaused, I'm just going to walk you through the equation. I went ahead and plugged in my initial velocity here is 12. Plugged in my final velocity is 0. 2 just came from the problem, or 2 came from the equation rather. Acceleration came from the problem as negative 3.5. And the reason why it's negative is it's slowing down. And then x minus 0. Our initial, remember, is almost always 0. And then plug everything in and do some algebra. And our final answer should be about 27.6. If you rounded that off to 20, or excuse me, about 20.6. If you rounded that to 20.6, that's just fine. All right, so how do I know which equations to use? This is kind of a common thing people are having issues with. So I put missing variables. These may be the things that you don't have. So if you don't have displacement, you need an equation that doesn't have displacement in it. So you're probably going to use velocity final equals velocity initial plus acceleration times time. Well, let's say you don't have velocity. Well, you can't use this top equation. So if I'm looking at those 3 equations, I don't have velocity final. So I can use this middle equation. And then let's say I don't have time. I'm going to have to use an equation that doesn't have time in it. So velocity final equals velocity initial plus 2 times acceleration times change in displacement. All right, so one of the things, you can use these for both horizontal motion, so motion in the x direction, or vertical motion, so motion in the y direction. You'll notice that on your formula chart, you'll see x in there several times. That just means in the horizontal direction. You could also do it in the y direction or the vertical direction. It's the same exact equation. All right, so acceleration from gravity, key thing to remember, acceleration due to gravity is always negative 9.8 meters per second squared. Here's what the negative means. Remember, negative tells us a direction, so that negative is telling us acceleration of gravity is pulling it downwards, and it's always 9.8 meters per second on Earth. If you go to a different planet, it will be different, but since we're doing our calculations here on Earth for now, we are going to use 9.8. All right, so here's an example problem. You drop a stone, so I've got my numbers there, and I want you to try to take a second and see if you can solve for this. We're going to try to solve for the height of the cliff. So pause here, see if you can come up with what equation you would need to use, and see if you can solve for it. All right, so pause, and then we'll come back. All right, so now that you've done that, you'll see that I've got the variables in there, and we're going to try to solve for the final height. So we're going to use this. So x, xo, or y and yo in this case because it's vertical. Plug in what we know. Well, walk through this problem. We're going to try to figure out how tall this cliff is. So plugged in what we knew, initial velocity being 0 because it was dropped, gravity, which is the acceleration, starting position, which is 0, and time, which we came from the problem as 5.78 seconds. And we're going to solve for basically the height, or how tall it is. So things that we know and things that we don't know. We don't know final velocity because they didn't tell us that. So I'm going to use this long equation and plug everything into it. Initial distance is 0, so I'm going to just ignore that when I put in my numbers. Velocity initial is 0. Time is 5.78. Now, one thing that you'll notice is those will cancel out. 0 times that is going to give you 0. Then plugging in 1/2 times 9.8 is 4.9 times our time. We get a negative 163.7 meters. And for the height, I just took off the negative. The reason why it's negative in this problem is the ball was being dropped. So the height of that is 163.7 meters. All right, another example. So pause the video here, try this one out, and then we'll come back and walk through it. All right, now that you've paused and you've worked through it on your own, hopefully you've come up with what the equation is. So if you've gotten that part, which variable is not given? Time. So we need an equation that doesn't have time in it. So pause and see if you can find which one of those 3 doesn't have time in it. All right, hopefully you've done that now. And the equation up there, velocity final equals velocity initial, both of those being squared, acceleration and change in displacement. None of those have time in it. We pulled the values from the question. Then we're going to plug everything in and see if we can solve for acceleration. One of the things, make sure, don't leave off the square. That tends to be a common mistake that people do. And then we'll just work through that. And hopefully by the time you get to the answer, the acceleration is 378.5 meters per second squared. So you'll square the 43.5. Go ahead and multiply 2 times 2.5. And then that'll give you 5, and then you'll divide 5 over. And that is how you get the 378.5. Another one, how long does it take a car at rest, which means it starts from 0, to cross 35 meters after the light turns green if the acceleration is constant at 2.00 meters per second squared? So I just wrote down what variables do I know. I know initial velocity is 0 because it says it starts at rest, and rest means 0 velocity. My distance is going to be 35 meters. My acceleration is going to be 2 meters per second squared, and time I don't know. Now, which variable do I not have? Well, I don't have the final velocity. It's not given to us. So I want to look for an equation that doesn't have final velocity in it. Oh, here we go. Distance equals initial displacement plus velocity times time plus 1/2 acceleration times time squared. Plug in what we know. The cool part is, notice this is going to be 0 from XO. If our velocity initial is 0, this is also going to be 0. And then we have 1/2 times 2. If we do 1/2 times 2, that gives us 1. And then to finish, we would have to take the square root of 35, which should give us 5.9, really close to 6, 5.92 seconds to be exact on that one. All right, another example. We're going to try to see in this one if we can figure out what the acceleration of this vehicle is. So wrote down the initial velocity of 12.5 meters per second, final velocity of 25 meters per second, and then the amount of time, 6 seconds. So what do I want to solve for? I want to solve for acceleration. So if I'm looking at this, I'm like, well, what do I not have in this equation? I don't have displacement anywhere. I do have velocity initial, velocity final, and time. So pause for a second and go, which equation would I need to use in this setup? Now that you've unpaused, hopefully, you said, I'm going to use my final velocity equation. We're going to plug our numbers in and do some algebra to solve for acceleration. which should come out to be about 2.1 meters per second squared when you do it. All right, your exit ticket for today, make sure that you have turned that in so that you get credit for attendance. And if you guys have any questions or anything, please send me an email or come in for office hours. Thank you all very much and have a great day.